Okay, this is problem 1511. We've got a three-layered soil. We've got a 40 centimeter diameter pile. It's 18.5 meters long. Um, and we have all clay. There's no friction. So these are all undrained parameters. So L is 18.5. Skimpton's method says Q sub B is 9. Basically, N sub Q is 9 for a friction value of 0. That's where that comes from. Times C sub B times A sub B, where the area, A sub B is the area of the base of the pile. And the text doesn't say this, but basically C sub B is the same as the undrained um, cohesion of the soil. C sub U at the bottom here is 150 kilonewtons per meter squared. The area at the base is pi d squared over 4. So the ultimate bearing capacity is 170 kilonewtons. So look at figure 1515 for the alpha method, and it's a function of the undrained cohesion. So C sub U1 is 30, C sub U2 is 50, C sub U3 is 150. So when you plug those into this chart, that's a best fit curve through there. Alpha 1 is 0.8, alpha 2 is 0.68, and alpha 3 is 0.38. Close enough. Those are the book solutions. They get you fairly close. The different lengths is L1 for the upper part, L2 is 6, L3 is 2.5. The circumference of the pile is pi d. So to get the area, I multiply the circumference times each one of these lengths, and that gets me the surface area of the pile. So it's real easy to just sum these up. So the total friction is equal to alpha 1 times Cu1 times the circumference of the pile times the length of that section, plus the same information for the second section, and then the same information for the third section. So that gets me to 737 kilonewtons. In this particular problem, for some reason, they wanted you to add Q sub B to Q sub F and then divide that by a factor of safety. And so when you do that, you get a total allowable capacity in bearing plus friction of the pile of 363.